Frequent question is about symmetry tests. Symmetry tests are conducted by substituting in a certain manner to see if the expression we get after substitution is equivalent to the original expression. To illustrate, symmetry test for symmetry with respect to the y-axis involves substituting negative x for x. So let's take an expression like y equals 5 plus x squared. Now we do the substitution. We substitute negative x for x. That means that instead of x, we're going to have a negative x here. So substituting, we get y equals 5 plus negative x quantity squared. Now the question is this expression equivalent to the original? And the answer is going to be yes. We see that by saying that y equals 5 plus negative x squared is equivalent to, and I'm going to write a double arrow here. It's like an equal sign with an arrow pointing this way and arrow pointing this way. This is equivalent to y equals 5 plus x squared, since the square of negative x is x squared. That's the same as the original. So we do have symmetry with respect to, that's what the WRT stands for, with respect to the y-axis. Now if we plot y equals 5 plus x squared, I'll do that here, you can verify that that graph goes through the point 5, 0, and the points 1, 6, and negative 1, 6, and it's a parabola. Okay, and that is symmetric with respect to the y-axis. If I have a value x here and project up to the point on the graph, so if this is my value of x, and I have then negative x over here, if I project up to the graph from this point negative x, well, I didn't draw the graph too well. Negative x has to be just a little further from the axis than that. That's probably too far, but you get the idea. And we go up to the point on the graph. We get the same y value. If we do 5 plus x squared and 5 plus negative x squared, we get the same thing, meaning that this point is a reflection of this one and vice versa. Again, the graph wasn't drawn completely accurately, but if you had a completely accurate graph, you'd see that. Of course, your text shows you that. As another example, try y equals 5 plus x squared. You should pause right now and do this one yourself. You just follow the same procedure we did here. Now, hopefully you've paused and done it so that you'll understand more completely what I'm about to do. Well, we're going to substitute. Substitute what? Negative x for x. So we get y equals 5 plus negative x plus negative x quantity squared. Is this equivalent? Well, y equals 5 plus negative x squared is equivalent to y equals 5 minus x plus x squared. Does this match up with the original? I can say it matches the original, except for the negative x. So the negative x here is different than what we have up here where it's a positive x. Everything else is the same. So there's no way this is equivalent to this. So, not equivalent. So, it's not symmetric.